Welcome to Educator.com. In today's lesson, we're going to continue on with matrices, and this time doing operations on matrices. Just as you can perform mathematical operations on numbers, such as addition, subtraction, and multiplication, you can do the same thing with matrices. Starting out with addition of matrices. Addition is defined only for matrices with the same dimensions. So just to review, when we talk about dimensions, the dimension of a matrix is m times n, where m is the number of rows and n is the number of columns. So two matrices must have the same number of rows and columns in order for addition to occur. If that specification is met, then you add the corresponding elements of the two matrices. The sum matrix will have the same dimensions as the original matrices. To illustrate this, let's say that I have two matrices, A, and then I have a matrix B, and I want to add those together. Well, let's look at my first matrix, A, and it will be 4, 0, 3, 1, negative 2, negative 4. Okay. And I have a second matrix, B, that I'm going to add. So A plus B. Okay, so first looking at the dimensions to make sure that I'm allowed to even add these. So 2 rows on this one and 1, 2, 3 columns. Therefore, this is a 2 by 3 matrix. Matrix B, 2 rows and 1, 2, 3 columns. This is a 2 by 3 matrix. Since these have the same dimensions, they can be added. The sum matrix, the resulting matrix, is also going to have the dimensions of 2 by 3. It has the same dimensions as these two original matrices. Now, to add these, I'm going to add corresponding elements. Recall that corresponding elements occupy the same position in the matrix. So if I'm looking at this position, this is 1, 2, so it's row 2, and then columns 1, 2, so it's row 2, column 2. The corresponding element over here is also going to be in this position of row 2, column 2. So all I'm going to do is add corresponding elements. So 4 plus 5 right here. And then I'm going to have 0 and negative 1. Over here, 3 plus 2. And down here, 1 plus 0. In this position, negative 2 plus 3. And in this position, negative 4 plus negative 5. Okay, which if I work out the addition on that, if I do the addition, that's going to give me 9, negative 1, 5, 1, negative 2 plus 3 is 1, negative 4, and negative 5 is negative 9. So again, first always verify that the two matrices you're being asked to add have the same dimensions. If they do, then you just add the corresponding element and put it in that same position to get the sum matrix, which will have the same dimension as the two originals. Matrix subtraction is very similar. Again, matrix subtraction is defined only for matrices with the same dimensions. To subtract two matrices, subtract the corresponding elements of the two matrices. The result, the difference matrix, will have the same dimensions as the original matrix. So same concept as with matrix addition. So looking at that situation here, if I have 3, 2, 4, negative 1, 0, 6, negative 2, 0, and this is A, I have a second matrix that I'm going to call B, and I'm asked to find A minus B. Okay. The difference matrix, which will be A minus B, over here. Okay, so first verify that these have the same dimensions. I have 1, 2, 3, 4 rows, and I have 2 columns. Over here, I have 1, 2, 3, 4 rows, and 2 columns. my difference matrix is also going to have 4 rows and 2 columns. Okay, so I simply subtract. 3 minus 6 is going to give me negative 3. Corresponding elements, 2 minus 0 is 2. 4 minus negative 5, so if I've got 4 minus negative 5, that's going to give me 9. Negative 1 negative 1 minus 6 is going to give me negative 7. 0 minus 2 is going to give me negative 2. 6 minus negative 1 is going to give me 7. Negative and a negative will give me a positive. Negative 2 minus 0 is negative 2, and 0 minus 1 is negative 1. So again, verify that the two matrices have the same dimensions, and then simply subtract corresponding elements. And since we're doing subtraction, you need to be very careful with the signs. Okay, now we're going to talk about scalar multiplication. And scalar multiplication is not the multiplication of one matrix times another. Matrix multiplication we'll actually cover in a separate lecture. This is called scalar multiplication because what you're going to be doing is multiplying a matrix by a constant. And that constant is referred to as a scalar. So, for example, if I'm given a matrix that looks like this, and I'm asked to multiply it by 2, well, 2 is a constant called a scalar. And let's say this matrix is called A. If I'm asked to find 2A, then I'm going to multiply the scalar by the matrix. In order to do that, you multiply each element of the matrix by the scalar. So each element of the matrix multiply by the scalar to get the result. Okay. Therefore, I'm going to say 2 times 2 for this position. For the second position in row 1, column 2, it's 2 times 3. Here, 2 times negative 1, 2 times 0, 2 times 4, and finally 2 times 1. Which, doing the multiplication out, will give me 4. 2 times 3 is 6. 2 times negative 1 is negative 2. 2 times 0 is 0. 2 times 4 is 8. And 2 times 1 is 2. And as you can see up here, the scalar product matrix has the same dimensions as the original. This original matrix had 1, 2, 3 rows and 2 columns. The scalar product over here, 2A, has 1, 2, 3 rows and 2 columns. So same dimensions as the original. Again, for scalar multiplication, simply take the scalar, the constant, and multiply it by each element in the original matrix. Just as we have certain properties when we're working with operations on regular numbers and variables, there are also properties that regulate matrix operations. So if A, B, and C are matrices with the same dimensions and K is a scalar, then the following hold. This first one you'll recognize as the commutative property of addition. Recall that with numbers, we have the commutative property where if you want to add 3 plus 2, you can add it in the other order, 2 plus 3, and get the same result. And the same is true if you're adding two matrices. So matrix addition follows the commutative property. The next property you may recognize as the associative property. And what for addition of matrices. Associative property for the addition, under addition of matrices. What this is stating is that I can do these operations in either order. I can either add the two matrices A plus B together, then add C to those. Or I can add B plus C together first, and then add A to those two. So I can perform these operations in either order, and the result will be the same. Now, looking at scalar multiplication combined with the addition of two matrices here, this follows the distributive property. And what this is stating is that I can add matrix A and matrix B and then multiply the scalar times that result. Or I can multiply the scalar times one matrix, multiply the scalar times the other matrix, and then add those two together, and then I'll get the same result. So this is the distributive property, which you've seen previously. First example, we're going to add two matrices. First, verify that addition is allowed. Do these have the same dimensions? 2 rows, 3 columns. Okay, so far so good. 1, 2 rows, 3 columns. Since these have the same dimensions, then addition is allowed. Okay, so rewriting these down here so we can work with them more easily. Recall that for addition, you're going to add corresponding elements. You're going to add the elements occupying the same row and column number. So 2 plus -4 is going to give me -2. -1 plus 6 is going to give me 5. 3 plus -2 is going to give me 1. 0 and -3 is going to give me -3. 6 and 0, I'm going to get 6. And then 4 plus 4 is going to give me 8. So all I had to do to find the sum matrix is to add the corresponding elements of these two matrices to get the result. Example 2 involves subtraction. And first, verifying the dimensions. 1, 2, 3 rows, 1, 2, 3 columns. So this is a matrix with 3 rows and 3 columns. So it's a square matrix since it has the same dimensions in both directions. Here I have 1, 2, 3 rows and 1, 2, 3 columns. So this is also a 3 by 3 matrix. So it's a square matrix since it has the same dimensions in both directions. Therefore, I can subtract these. So in order, when I go ahead and subtract, I'm going to get a difference matrix that is also 3 by 3. Beginning with these two corresponding elements, 2 minus -1. I have to be very careful when I'm working with negatives that this becomes 2 plus 1, which is 3. So I get 3 right here. -1 minus -2. So -1 minus -2 is going to give me -1 plus 2, which is 1. Here I just have 6 minus 3. That's 3. 3 minus 0. That's 3. 2 minus 4, and that's just going to be 2 minus 4 is going to give me -2. 0 minus -8, so working down here, 0 minus -8 is going to be 0 plus 8, which equals 8 in this position. 1 minus 6, so 1 minus 6 is -5. 4 minus 0 is 4. And then 3 minus -1 gives me 3 plus 1, which equals 4. So again, with subtraction, just being really careful with the signs. And I end up with a difference matrix right here that resulted from subtracting, taking an element in the first matrix and subtracting the corresponding element of the other matrix from that. Example 3 is find the product, and it's the product of a scalar and a matrix. So this is scalar multiplication, and here the scalar is -2. So rewriting this down here. Recall that in scalar multiplication, you're going to multiply the scalar times each element in the matrix, and the result is going to be a scalar product that has the same dimensions as the original. My original here is a 3 by 3 matrix. So I'm going to take negative 2 times 2 for the first position, negative 2 times negative 1, negative 2 times 6, negative 2 times 3, and continue on multiplying each one. Negative 2 times 0, third row, negative 2 times 1, negative 2 times 4, and finally, negative 2 times 3. Then when I do my multiplication, I'm going to end up with negative 4, 2, negative 12, negative 6, here's negative 4, 0, negative 2, negative 8, and then negative 6. So again, scalar multiplication, simply multiply each element in the matrix by the scalar to get a scalar product matrix with the same dimensions as the original. Example 4 is slightly more complicated. We're asked to find negative 3a plus 6b. Okay, so what I need to do is multiply matrix A by negative 3, multiply matrix B by 6, and then add those together. Just to make sure I can add them eventually, I verify the dimensions as 3 rows, 2 columns, and 3 rows, 2 columns. So I will be able to add them. Okay, just to note, looking at the distributive property, that says that K, a scalar, times A plus B, these two matrices, equals Ka plus Kb. So there's actually another way I could do this. I could say, all right, I'm going to factor out that the 3, or the negative 3 actually, and then I'm going to end up with A minus 2b. This would be another way to do that. However, it's a toss-up which way is easier. I'm going to go ahead and just follow this original, but you actually, if you felt like this way is easier, could have done it this way. Okay. Okay, so starting out, the first thing we're going to need to do is, excuse me, multiply by A by negative 3, the scalar negative 3. Okay, and from that I can find 3a. I want to find 3a. So this is negative 3 and a, and I want to find 3a. Negative 3a. Okay, so recall that all we're going to do is multiply each element of the matrix by the scalar. And that will give me 3 here. Negative 3 times 0 is 0. Negative 3 times 2 is negative 6. Negative 3 times negative 1 is 3. Negative 3 times 3 is 9. And let's see, then I've got negative 3 times 4 is negative 12. Okay, now what I also need to do is find 6b. Okay, so here I have 3a. I need to find 6b. So I have b over here, 0, negative 3, negative 4, 6, 4, and 9. So I have b. I'm going to multiply it by 6, and that's going to give me 6b. So figuring this out, it's 6 times 0 is 0. 6 times negative 3 is negative 18. 6 times negative 4, negative 24. 6 times 6, 36. 6 times 4, 24. And 6 times 9, that's 54. All right, so here I have 3a. Here I have 6b. Now I need to add those. So let me go ahead and copy 6b right over here so I can add it. Okay, 0, negative 18, negative 24, 36, 24, and 54. Okay. Now, erasing that, these two are no longer equal. Okay. All I need to do with matrix addition is to add the corresponding elements. So I'm going to add 3 and 0. And this is going to give me 3. I'm going to add 0, negative 18 to get negative 18. Negative 6 and negative 24 is negative 30. 3 and 36 is 39. 9 and 24, excuse me, this actually should be negative 9. Correct that. That's negative 3 times 3, that is negative 9, plus 24 is 15. And then I've got negative 12 and 54 to give me 42. So this here is negative 3a plus 6b. So right here is my solution. And what I did is I took a, I multiplied it by a scalar negative 3 to get this, 3a. I took 6 and I multiplied it by the second matrix b to get 6b. Then I added 3a plus 6b to get negative 3a, it's negative 3a actually, plus 6b as my solution. That concludes this lesson on matrix operations at educator.com. I'll see you next lesson.